Hello everybody, my name is Caio and today I'm going to solve a convolution problem using Laplace Transform. First of all, we need to remember the Laplace convolution property that says that if we have two functions f1 of t convoluted with f2 of t, if we apply the Laplace transform in these two functions, the Laplace transform will be the multiplication of the Laplace transform of each function separated, that is f1 of s times f2 of s. So we can use the same idea in this problem. The problem asks us to calculate the convolution of t convoluted with sine of t minus exponential of t. Applying the Laplace transform in this convolution, we have the Laplace of t that multiply the Laplace transform of sine of t minus exponential of t. And again, we can use another Laplace property that says that the Laplace of the subtraction of two functions is actually the subtraction of the Laplace of each function separately. That it is equal to Laplace of t times Laplace of sine of t minus Laplace of e of t. That is equal. Now we know the Laplace of each function separately. So we have that Laplace of t is 1 over s squared that multiply. The Laplace of sine of t is 1 over s squared plus 1 squared minus 1 over the Laplace transform of exponential of t, that's equal to s minus 1. Now we need to simplify our equation to apply the inverse of the Laplace transform. So first of all, we are going to distribute 1 over s squared in these two terms. That will be equals to 1 over s squared times s squared plus 1 minus 1 over s squared times s minus 1. Now we are not going to apply partial fractions because it's too difficult to calculate the constant for this one. That will be a complex number, and this one is a second multiplicity. So we need to see this numerator different than 1. Right, is equals to 1 but write it in a different way. So we can call this one as a combination of these two terms. That will be s squared plus 1 minus s squared. Actually, this numerator is the 1, but it is written in a way that we can simplify our equation. S squared times s squared plus 1. The same thing we are going to do with this second one. We're going to rewrite this one as a combination of these two terms that will make our life very easy. That is s minus 1 over s squared times s minus 1. Now we can open this numerator in two parts. That will be s squared plus 1 over s squared just to rewrite s squared that multiply s squared plus 1 minus s squared that multiply s squared times s squared plus 1 minus s that multiply s squared times s minus 1 minus with minus plus s minus 1 that multiply s squared times s minus 1. As you can see, we can simplify a lot of terms here. Sorry, this one, this one. So we can rewrite our function as 1 over s squared minus 1 over s squared plus 1 minus 1 over s times s minus 1 plus 1 over s squared. That's equal. We're going to do the same thing with this denominator. The same idea we are going to apply. It is equal to 2 over s squared minus 1 over s squared plus 1 minus useful numerator for this term will be s minus 1 over s times s minus 1. That will be equal to 2 over s squared minus 1 over s squared plus 1 minus s will simplify with this s in the first one. That will be minus 1 over s minus 1, and this s minus 1 will simplify with this s minus 1, and we are going to, and this minus signal will become a plus signal, plus 1 over s. Now we found a finally equation. We are going to come back to time domain. So we are going to apply the invert of the Laplace, the inverse Laplace transform. So we have that L minus 1 of this term is equal to the Laplace transform of each term separately. So it will be equal to inverse Laplace transform of 2 over s squared minus the inverse Laplace transform of 1 over s squared plus 1 minus the inverse of the Laplace transform of 1 over s minus 1 plus the inverse of the Laplace transform of 1 over s. Finally, we have that the inverse Laplace transform of 2 over s squared is equal to 2t times our step function. Step function t minus this one is the inverse transform of 1 over s squared plus 1 is actually the sine of t times our step function minus this one is our exponential of t, minus the exponential of t times our step function, and the last one is just our step function. We can put our step function in evidence, and we finally has that the t convoluted with sine of t minus exponential of t is equal of 2t minus sine of t minus exponential of t plus 1 times our step function. And you can see how the Laplace transform can make our life easier in calculate convolutions. Thank you for listening. Bye.